Okay, one of the first factor that we're going to be talking about is surface area. Surface area. How the surface area affects the reaction, the rate of reaction. Now, in the textbook, I'm going to talk about the ones that they mentioned in the textbook and how they describe it to be measured, as well as I'm going to do some demo. That's why from time to time I'll pause and I might ask one of you to record my demo so that I can put it up on the website. Done. Now, combustion reactions. A lot of combustion reactions, that's a one that they gave example on the textbook. Essentially, anything kind of burning you can speed up the reaction or slow down reaction. Now, one thing that I want to ask you guys beforehand, how many of you guys know or have started a wood fire before? How many of you guys have started a fire with wood before?
Without matches?
Oh, I mean like with matches. Not like not like drilling two wood together, rubbing two sticks. Okay? Yes, you have done it. So when you start a wood fire, do you start off using big pieces of wood or small pieces of wood? Yeah, you start off using small pieces of wood first. You don't start using a big log because small pieces of wood will have a lot more surface area for the combustion reaction to happen. That's why when you start a campfire, you always have using those small woods or small sticks, and then you build your fire on top. Okay? Surface area. So that's how it improves the surface area. In the textbook, they talk about powdered flour they pour powdered flour into flame. Now, it's hard for you to do an experiment with that, but since it's in the textbook, I will mention it and show that picture. So here in this picture, you can see the guy pouring powdered flour onto a fire, and you can see this fireball going pretty fast. That's because there's high surface area of the flour, so the flour can burn really quickly. I'm also going to quickly show you a Mythbuster video. Now, instead of a fire, they use a creamer, okay, those non-dairy creamer.
That stuff goes up in the air and it actually ignites. We could set this whole hillside on fire.
I'm either expecting to see a much bigger mushroom cloud of fire, or because it's heavier, we're going to see, and it's going to catch on fire, and then we're going to stand there and watch it burn out. Hopefully, choice A.
Grant slowly builds the air pressure to 120.
There you go.
Then Tori sets the spark.
So if you look at it, the spark is only really from that flare. So it's only from that flare. It's not like a big flame to start the whole thing on fire. So, but look at how what happens first.
The volume of air is crucial. This could either be a blast or a burn.
All right, fire this puppy up. All right, here we go. Non-dairy creamer cannon. In 3, 2, 1.
Now, they are just shooting up these dairy creamer as a powder form, just spread it over the air. Okay, so that increased the surface area. Now watch what happens.
Ooh. That was frightening. Terrifying. Did you get that on high speed?
Yeah, we did remember to push the on button on the off chance that this might be one of the biggest fireballs ever.
This was frightening.
So as you see, remember, they press the button that all the creamer spread all throughout the air that in this case, maximize the powdered, sorry, it's not on the screen. So that in this case, it maximized the surface area between the powdered flour, and oxygen. And then the fire start catching. Do you guys follow so far? There's a surface area thing. Now, Another one that I'm going to talk about is this. You have seen this reaction before. CaCO3, calcium carbonate, and HCl, hydrochloric acid. Now, when you see this reaction, it forms carbon dioxide gas as well as water and calcium carbonate. You have seen this reaction back before Christmas time, okay? And at this point, I am going to show you a demo just to remind you what happened. Okay. Now, so what we can measure. What we can measure. Now, we can collect the gas. The gas, CO2, and compare volume of gas collected over time. Okay, so in this case, volume of gas might be in milliliter and might be in liter. You don't know. It depends on the experiment. In fact, this idea was mentioned in the textbook for a different experiment, but it still can work. So if you look at the textbook, figure 7.17, there's this diagram of a different experiment. So you see a reaction flask. There's a stopper. The reaction's going on here. The gas gets generated, get collected by a gas syringe. As the gas is being made, the gas will push the syringe, and then you can see how much gas was generated over a timer. Do you guys follow so far? So this is in page 7.17. So, not page, figure 7.17. So you can collect the gas, or you can, because carbon dioxide is a heavy gas, because CO2 is a heavy gas, then in this case, you can measure the rate of mass loss over time. You can measure the rate of mass loss over time. In fact, this is the demonstration that I've done before Christmas, as well as there's on the textbook, there is this diagram setup, figure 7.14. As you can see, a reaction flask. Now this one here, they have marble chips. Like, so rather than powdered CaCO3, they have pieces, chunks of CaCO3. And then you can see how long it takes for the mass to go down. Do you guys follow so far? So this is on figure 7.14. This is another way to set up or do this experiment. Yep.
Like on figure 7.14 with the whole mass thing, are we measuring the mass of the marble chip or?
You measure the mass of the whole thing, all the acid, all of the marble before,
Okay.
and then when you put the marble in, you start the timer, and then you see, oh, as time goes on, you notice the whole flask reaction, the mass goes down because the carbon dioxide gas escaped to the atmosphere.
So the mass so the change in mass of both hydrochloric acid plus marble chip.
Plus marble chip, plus the Erlenmeyer flask in that diagram, and the cotton that's plugging it.
But for the flask, isn't it going to be set at 0, like that?
Yes, but then the thing is that it depends how you decide on the experiment. That's where I'm not going to talk about it. Okay.